Here is the series. You see the series I have underlined, and nth term of this series is nth term equals to 1 by n to the power m 1 plus 1 by n to the power p, and the same thing can be rewritten as 1 by n to the power m into n to the power p 1 plus n to the power p. And now if you let n tends to infinity to this part, if you tend n tends to infinity, then the enclosed part will be a finite number. So nth term of the auxiliary series will be 1 by n to the power m. And now let this to be un and this to be vn. Okay, now we find the limit lt n tends to infinity un by vn. Then this will be lt n tends to infinity n to the power p by 1 plus n to the power p. Now the value of this limit will be 1 when p is not equals to 0, and will be 1 by 2 when p equals to 0. So we have the value of this limit. The value of this limit, you see, the value of this limit is a, in each case, whether p is 0 or not, irrespective of the value of the p, the value is a non-zero finite positive number. Okay, so the nature of this series, and you know this series is nothing but this one that is in our question. The nature of this series depends upon this series, you know, this series 1 by sorry, here will be vn, and you know this series is nothing but this one, and you know this is convergent when m is greater than 1. Okay, so if you see this thing and this thing, you see the sorry, not this one, this one. If you take these two into account, I show you again this one and this one. You see m is greater than 1 irrespective of the value of p. So for the convergence, since this series is convergent, for this value, for this value. So for the series, this series to be convergent, the value of m must be greater than 1 and the value of p may be anything. So the correct option will be A. Okay, so this question is done now.